Hello, grade 9 students. This is October 2021 monthly test paper. Right? We will move through one by one here that you can see the instructions, answer all the questions, and show your workings clearly. Right? So then the first question we have, it is from the recurring decimals. So then when you have something like this, can you remember, wait, I will better to open the whiteboard and show you the steps. So then here, the first question we have, children, Roman number 1, I write here 0.93 recurring, right? 0.93 recurring. What does this mean, children? 0.93, 93, 93, 93, it's going on, so that it's repeating, right? And then I name this as X, 0.939393. This repeating thing I name as X and I number it as number 1. Then here you have 2 digits in the recurring cluster, right? You have 2 digits in the recurring cluster. You can see 2 dots here. So what you do, you multiply the equation 1 by 100. How we are going to decide it? Here that we can see 2 digits in the recurring cluster. And it's the 10th place and the 100th place, right? If the 10th place and the 100th place, so that unit, that cluster 9 and 3, it's repeating. Now what happened here? This become 100x and then this become 93.9393 like this. Okay, so this is the second equation. Now, so this is very similar to the simultaneous equation. Now what happened? I deduct the equation 1 from equation 2. What happened? 100x minus x equal to 93.9393, and you deduct 0.939393 recurring. So then here I get 99x equal to 93 and x is equal to 93 over 99. Okay, so 93 over 99. So that is the first part. And the second part of the question here, the Roman number 2, we do have 0.027, 0.027, but only 2 and 7 are recurring. Now how we are going to elaborate this? 0.027, 27, 27 like this. And I name it as X, right? 0.027, 27, 27, 27, right? And I name it as number 1. I number it, right? Now here, children, now you might think here also that we have 2 digits in the recurring cluster. Therefore, I should multiply by 100. No, this is different from the earlier one. Earlier one, you can see the recurring cluster, 2 digits, they are in the 10th place and the 100th place. But now what has happened, the 2 digits are recurring, but those recurring digits are in the 100th place and the 1000th place, right? And the 10th place, that whatever the digit you have, it is not recurring. So then what we do in that case, we multiply 1 by 10. It gives me 10x and it gives me 0.27272727 and recurring. So this is equation 2. And then here we have the recurring cluster digits in the 100th place and the 1000th place. What I do, I multiply this by the second equation by 100. The second equation I multiply by, right? I multiply this by 100 or else you can do straight away. You can multiply the first equation by 1000. Now what happened? It gives me 1000x, okay, and here that becomes 27.272727 like this, and this is the third equation, okay. And then what I do, children, I subtract the second equation from the third one, so that becomes 1000x minus 10x equal to 27.272727 subtract 0.272727 like this. So what will be the answer, children? This become 990x and this will become 27. So then the x is equal to 27 over 990, and I can simplify this. I divide this by 9. It gives me 3 over 110. Okay, so then don't think that looking at the number of digits in the recurring cluster we can just multiply. No, we have to think that here in the Roman number 1 you multiply it by 100 because both the digits in the recurring cluster, one is in the 10th place and the other one is in the 100th place. But the next one, that you have two digits in the recurring cluster but they are not in the 10th and the 100th place. Instead that they have, we can see them in 100th and the 1000th place. Therefore, that this the recurring number we want to multiply by 1000, but before that we multiply by 10. You can see that in the 10th place it is not recurring, so you take it like this, right? So then 27 over 990, right? So then we will move to question number, Roman number 2. Sorry, this is not Roman number 2. Actually, it is Roman number 1. This is how I want to number it. This is question number 1, Roman number 1, and part A. And this one, it is part B. It is part B. Then we want to go to Roman number 2. Roman number 2. Roman number 2, you want to correct to 3 significant figure, the third significant figure. So we will take the first one, 4,786. Is it? 4,786. Yes. So then what we do, we underline the third significant figure. This is the third significant figure. Then you look at the next number. So then what happens? If the next number is 5 or more than 5, we need to add 1. To where we need to add 1? To the underlying number that here we write 4, 7, 9 and 0. Inside the bracket you write, you corrected this to third significant figure like this. Okay, 4,790. And then part B, they have given you 0.02643. 0.02643, and here this is the third significant figure. Children, keep that in your mind. These two zeros are not significant figures. Always you want to keep in your mind, if you come across with zeros in the front, you don't consider them as a significant figure until you come across with a digit which is in between 1 and 9, right? So then to identify a particular number as the first significant figure, that number always should be a number between 1 and 9. It can be 1 or more than that, 9 or less than that. If you come across with zeros, they are not become the first significant figure. But after identifying the first significant figure, for an example, if you have 0.002035, so these are not significant figures, but this one will become a significant figure because this 0 you can see after the first significant figure. Okay, if you come across with a 0 which is after the first significant figure, maybe immediate or that after few digits, that counts as a significant figure, but the zeros you can see in front of the number, they are not the significant figure, right? Now here, this is the third significant figure, and you look at the next number, and it is less than 5. If it is less than 5, we don't change anything. We just write the number as it is, 0.0264, and we can see the last digit 0, but no point because it's a decimal place. But here, writing the 0 is more important, because if you skip the 0, it gives a different meaning. But in the exam, the question B, if you skip the 0 at the end, it doesn't give you any change, because the value doesn't change with the 0, the last zeros in a decimal number. So then here I write 3SF. Then the next one, we have Roman number 3, right? We have Roman number 3, and there we have 8.4352. 8.4352. And what you are supposed to do, you want to correct this to the second decimal place. So this to the second decimal place. How we can do that? First of all, you want to, I write 4352 and I underline the second decimal place. After underline the second decimal place, you look at the next number. If the next number is 5 or more than 5, we need to add 1. To where we need to add 1? To the underlying number. So this becomes 8.44, and then rest of the digits will be 0. You can just write it, and then you can conclude 8.44, and inside the bracket we write 2dp. Right? So then we will see that what is the part B. Part B is like this, 1dp. So the same number, 8.4352, 1dp means this one. This is the first decimal place. You look at the next number. If the next number is less than 5, we don't do anything. We just write the number 8.4. The rest of the digits will be 0. So then we can just write 8.4, that is 1dp. Okay, this is how you write the answers. So then we will move to the Roman number 4. Roman number 4. So it's the calculator version. Children, here you want to do something. So you want to take your calculators, right? And you want to do it with me, because the step by step we want to do it. Now here, that first you want to put the, that you want to press the square root sign. Okay. Then what you want to press? 6.43, 6.43. Then you know that you have to the power thing, 43 to the power 2, to the power 2. Sometimes you can have this something, right? And sometimes you have this something and 2, right? It depends on the calculator type you are using. 6.43 to the power 2. Then you write the division, right? Then what we have, you open the bracket, right? So then we have 5.45, 45 plus. So you just type it with me, 5.45 plus, and 3.2. So then we have 3.2. 3.2. Then you click the equal sign. Right? You click the equal sign, and that if you don't get this, so then here I use the wait, 6.43 square, right? And you divide it by 5.45 plus 3.2 and 4.7797. 4.7797. 7797. Yeah, here that they have given 6.43. 6.43, right? So then you have the square and you divide it by, so we will take 5.45 and 3.2. That here the answer is, when you add these together, that is 8.65, right? And 6.43 square, what is the answer? It is 41.3449. So then what you're supposed to do, that in the calculator you can get it at once, but I'm showing you 31.449 divided by 8.65, right? 8.65. So then we have 30, so not 31, 41. 41.3449. 41.3449 divided by 8.65. It gives me square root of 4.779757. So then here you can straight away you can get it from the calculator. So then 41.3449, 8.65, 4.779757. The answer gives me 2.1862. The earlier method also we got that when we have 6.43 to the power 2 and divide by, then we have 5.45 plus 3.2, and you get the answer 2.1862. But what they have asked us to do, correct it to the third significant figure, 11862. Here also we get the same answer. And the third significant figure is this. And look at the next number. So then this will be 2.19 and 3SF, third significant figure. Okay. So children, that we discussed the first question. And after that, we want to write 392 as the product of its prime factors. Now we are moving to the question number 2. In question number 2, we have 392. So how we are going to get it? 392 we divide by 2. It gives me 196. Again I divide this by 2. It gives me 98. Again I divide this by 2. It gives me 49. And then I can now divide this by 2 and 3, 5. Then I get the next prime number 7. 7 times 7 and 7 times 1. So then I can write 392 like this. 2 times 2 times 2 and 7 times 7. So then 392, that is 2 to the power 3 and 7 to the power 2. Okay, that is how we can write. And the next question, it says you want to find the LCM of 12 and 20. So these questions are very easy, children. So this is Roman number 1. This is Roman number 1. And then I can write Roman number 2. That is 12 and 20. So then we write 12 and 20. Okay. So then 2 times 6, 2 times 10. Again, you divide this by 2 times 3 and 2 times 5. Then you divide this by 3, 1 and 5. Then again, I divide this by 5, 1 times 1. So then how I'm going to get the LCM of 12 and 20? So then the 2 times 3 times 5. 2 times 2, 4. 4 times 3, 12. 12 times 5, 60. So LCM of 12 and 20, it is 60. What is the next question we do have? Again, to find LCM, 5, 15, 90. What we do the same thing. 5, 15 and 90. We start dividing this also by 2. So then 2 times that we don't have, and 15 we can't divide, and 45, right? And then we can divide this by 3. 5, it is not divisible. 3 times 5 and 3 times 15. I can divide this again by 3. 5 and 5 I keep as it is, and this one also 5. And then this one, it is 1, 1, 1. So then how we are going to get the LCM of 5, 15 and 90? You do the same thing 2 times, 3 times, 3 times, 5. 2 times 3, 6. 6 times 3, 18. And then 18 times 5, it is 90. LCM of these numbers, it is 90. Then we will see what we have, the highest common factor. Children, how we are going to find the highest common factor? So different teachers, they do use different methods. I will explain that what method I'm using, that when I have two numbers 16 and 12 like this, I first write down them. And I write down the factors of these numbers. 1 times 16, 2 times 8, and 4 times 4. That's it. And then 1 times 12, 2 times 6, and 3 times 4. That's it. Out of these numbers, I circle the numbers which are common. 1 common, 2 common, 4 common. Yeah, that's it, right? So only these 3 numbers are common. So out of these, the common numbers are 1, 2, 4, right? So then I write here the common factors. Common factors of 12 and 16. I can list down them 1, 2, 4. Those are the common factors. Out of these common factors, I highlight this as the highest common factor, right? The highest common factor, right? So we identify the common factors. Out of that, what is the highest common factor? Then 20, 8, and 12. We do the same thing, right? 20. If you have practiced any other method, totally fine. You can continue with 28 and 12. But you just see that how easy this is. 1 times 20, 2 times 10, and 4 times 5. 1 times 8, 2 times 4. 1 times 12, 2 times 6, and 3 times 4. Then we circle like earlier the common numbers 1, 1, 1. Then I have 2, 2, 2. Then I have 4, 4, 4. What else? So no, we don't have any other number in common. So then we just write the common factors of common factors of 8, 12, and 20. How we are going to list down 1, 2, 4, and this 4 will be the highest common factor. Highest common factor. Okay. Then we will move to the next question. Here that the 3 to the power 2, 3 to the power 2 and 3 to the power 4. So then here 3 to the power 2 plus 4. Simply you can write 3 to the power 6. You don't want to find the value, that you can just keep it like this. X to the power 5, next one, x to the power 5 and x to the power 4. So then here we can show that the x to the power 5 minus 4, because it's the same, the base value, and then the division, you subtract this x to the power 1. If need, you can write this as x, right? This is how you want to write the answers. Okay, children, so then we want to discuss from question number 3 onwards, but I'll take those questions in a separate video, because this becomes a very long one if I'm going to complete the whole thing. So the next video I will explain question number 3 onwards. Okay, children, we'll meet again with the next video. Till then, stay safe. Bye.